Hare Krishna. Hope you are doing well. Let's get started with this question on bivariate normal and MGF. So just looking at these exponent terms should remind you of MGF, and we'll get to it in a bit if it's not hitting you right now. You just have to find the correlation coefficient between these two. But when we use the theory to define the correlation coefficient, it is expressed like this: covariance divided by the product of standard deviations. Standard deviation itself is the square root of variance, so that, and the covariance can be defined like this, and the variance can be defined like this. And so all of it boils down to computing these kinds of expectations where it's e to the power some random variable to which it is raised. Naturally it should strike, the MGF should strike. Computing these parts are relatively easy because they're direct, even this ones, right? They're directly involving just single random variables. But what about this? It may confuse you that, okay, do I have to look to a double MGF, two-dimensional MGF? What exactly? But simply just one step away is this simplification, that this can be looked at as the MGF of this random variable, a single dimensional random variable. And again, we can remember that the linear combination of normal random variables in the bivariate distribution is going to be a normal distribution also. So we simply find its expectation and variance, and we know that this variable is a normal variable with this mean and this variance. Then at the end, all we have to do is plug in the MGF formula. And it's important to remember this formula for the normal distribution with any mean mu and sigma square. This is what the value of the MGF is. Uh, Especially the sigma square divided by 2 factor is there, and then we just substitute for all of the MGF terms in our process. We substitute this mechanism to get the value. Over here the mean is, everywhere the mean is 0. Actually it's all about sigma square by 2, the variance by 2, and this constant part t is simply 1 because here it's like 1 multiplied by x plus 2 by 1 multiplied by x. Here it's 2 multiplied by y. So that is there. That adjustment and all is there. And finally, when we have all of these values, this can be substituted. This can be substituted over here. And the components over here are substituted over here. And we get this thing as the answer. Straightforward. This was it. Take care. Hare Krishna.